So remember when, yes, it's okay to determine f of x plus age on the side, awesome. But when you put it in here, remember two things have to happen. All terms without age have to go away. Then you have to simplify by factoring, simplify the age, because this has to go away. And then you apply this limit to this expression. And the limit cannot go away till the last step. I think out of 15 answers, I think I got 12 different ones. I'm not kidding on this. Then you plug it in and you get negative 22. Now here, sorry about that, I have to change that into 1 over x. And yes, this is not this. And this is not this, and this is not this, because I copied the problem incorrectly. So I have to change that. Here, if you read the question carefully in Canvas, I said you don't have to do this again. You don't have to go through all these steps again. There is no need. I said you can use the differentiation rules. So once you use the differentiation rules and you get negative 2x, all you have to do is just plug it in y minus y1 equals the slope times x minus x1. You plug in negative 1 in f prime and you get 2. And you just write the equation. You didn't have to do this. I said, please don't. You already showed me this method, right? The only formal definition that we have for f prime. And many of you just dropped the limit. You just said that f prime is this. Please don't write that. I can't give credit. It's incorrect. You cannot say that f prime is this. No, it's not. F prime is the limit of this. We never wrote f prime is some ratio. Unless we are using the quotient rule, it's a different story. Okay, so please do not drop the limit operator. Then, here I wanted you to explain, not that, okay, the function is not differentiable. No, you have to say x1 is a corner, x2 is a corner, x5 and 7 not continuous. 3, 4, 6, 9, and 10, the same thing, either corner or cusp. You have to list and explain why. Most of you got this correctly. We had an example in class, so if you just watched that video or did it again, it was exactly the same. So you have a horizontal tangent at 0, horizontal tangent, a turn at 2, horizontal tangent at 4. Here, the same thing. You didn't have to do anything but just write that 2x over 3 is 2x times 2 over 3 times x and differentiate, and you get 2/3. Because x prime is, can anyone tell us how much is x prime?
1.
Perfect, thank you. Good, so here, you determined this correctly. Many of you did not write the degree, so this is, I always write that the measurement unit for temperature is this, the measurement unit for T is this. So always remember T prime, F prime, whatever, has to have 2 measurement units. It's the rate of change of temperature with respect to time. The rate of change of temperature with respect to time. So again, I'm going to consider this extra credit. It will appear as if it's out of 0. And I will kindly ask you to work on some other problems that are similar to this, to these problems. Is that okay with everyone?
Yes.
Yeah.
Perfect. Do you have any questions? Is there any particular type of problem that you want me to, or you want us to go in class over in class again? Any type. And please remember, do not drop the limit operator. The derivative is the limit of the difference quotient. It's not just the difference quotient. Okay, what would you like to start with? Any questions? Anything that you worked on?
Can we do 26 from today's homework?
Yes.
Yes, please, because I also got confused with it a little bit.
Perfect. So today is the 15th, right? Would you tell me which page so I can share my screen?
Page 163.
The book is here. And you oh, I'm logged out. Okay, fine. It always considers. So you said to 163. 163. Thank you very much. On 163, number 26. Very good. So 163, so we have f of x equals negative 3x squared plus 4x, and in parentheses 7 the square root of x plus 1. Okay, so let's work on something. I worked with one of your colleagues today, so let's do that first. Let's refresh our memory. When we differentiate 1 over x, some rules.
Negative 1 over x squared.
Excellent. When we differentiate x prime,
It's 1.
perfect. When we differentiate any constant,
0.
perfect. Awesome. So these are a few things that we looked at from the very beginning of the differentiation. But now let's also look at the square root of x. For this, we refreshed our memory on exponential rules. Can anyone tell us how do I change this into an exponent?
X 1/2.
X to power 1/2. Awesome. Excellent. So let's differentiate. So we know this from now on forever. It's a very important result. So let's do it together. We are applying here the power rule, right? We're not, this is the lesson from last time. This is not a quotient. This is not a product. This is the power rule. So how do we handle the power rule? Can anyone tell us what is the power rule? I muted everyone just because we don't want to have any background noise. You already have me. That's your background noise.
Bring the exponent.
Yes, I'm ready.
Bring 1/2 down and multiply it by x, and then subtract 1.
Yes. This is the power rule. Bring down the power. Thank you so much. And subtract 1 from the power. All done. Very good. So 1/2 minus 1, we have to know that this is negative 1/2. So 1/2 times x to negative 1/2, and we discussed this power, a negative power, 1 over 2, x to 1/2, but that is 1 over 2. How do I go back from x to 1/2 back to the square root?
To square root of x.
That's it. So here's another very important rule that we have to carve in stone. So whenever we have the square root of x prime, what should I write as the answer? Forever and always.
1 over 2 square root of x.
Thank you so much. Okay, so this is carved in stone. This is carved in stone. This is carved in stone. And now this one. So all we need to do, in case you forget, you have to change it into a power and then use the power rule. Great job. So now we are ready for f prime of x. And remember, 1 times 2 prime. Write the formula till you get used to it. 1 prime times 2 plus 1 times 2 prime. Let's say you go to the testing center, you go to the math lab and they teach you this. It's okay. Fine. Same thing. Let's say they switch these two. Fine. I do not like these. I accept them. Fine. They're fine. Only because we all develop our own style. You use the style that fits your narrative or whatever you decide that it works for you. I'm fine. I prefer 1, 2, 1, 2, 1, 2. I don't like twisting them. But you can say this works better for me. I'll say awesome or okay. Use it. Again, I don't want to enforce any particular rule on you, but I personally prefer 1, 2, 1, 2, 1, 2. The first one is prime and then the second one is prime. Okay? So this is what I have to use for f prime. So let's do that. I'm going to write f of x here one more time because it's up there. Negative 3x squared plus 4x and 7 the square root of x plus 1. So can anyone give us the first piece? This one.
Negative 6x plus 4.
Excellent. Now I have to copy this. 7 the square root of x plus 1. Now I'm here, plus. Now I copy the first one. And times. I should continue, but I don't have enough room. Now I'm here.
Seven over 2 square root of x.
Excellent. And it's fine if you just stop there. You can distribute. We may be able to simplify it a little bit, but I'm fine if you just stop there. Question, do we understand the steps now? Is that a yes? Is that a no?
Yes.
Perfect. Is there anything else we need to go back to? Anything that you want from MyLab Math, from what we covered last time, from any homework you want to review, anything? Any other question?
So for that problem,
Yes?
so you said it's fine if we just stop there, but like some other problems we have to keep going. So when do we know?
Yeah, we can. It's a very good question. So we can further simplify. I have to distribute here and distribute here. It's unlikely that I will be able to simplify too much because of this square root in the denominator. And then I have to find the least common denominator, which will be 2 to the square root of x, and I can continue. It's a very good question. So you will see in chapter 3 when we simplify. Okay? This is an exercise in applying the product rule. We're not using the derivative at this point till chapter 3 for anything else. That's the reason why I don't really care if you continue or not, you just stop here. In chapter 3, we will have no choice. In chapter 3, we are using the derivative for something else, and we will need to completely simplify it. And you will see why. It was a perfect question. Thank you. Right now, I'm okay, because we're not doing anything with this derivative. But later on in chapter 3, it's going to be a big deal to simplify this. Big. Excellent question. Thank you. As I said, some of you are way ahead of me. That's awesome. Okay, any questions? Is there anything else we need to address? MyLab Math or otherwise? Anything? Okay, so in that case, I would like to try to finish if we can today, so we can review and review and review for test 1. So we are looking at 1.7, and we said this is the last rule for now. It's called the chain rule. And as I was saying last time, the last page here of the notes, we know how to differentiate a sum, a difference, and now we know the product for sure, and we know the quotient. But many times we have an inner function and an outer function. How do we differentiate this? So I'm going to put this in the recycling bin and start from scratch. Okay, so if you remember, when we differentiated x to a power n, can anyone tell us what to write here? So it's okay if you're making a mistake, if you're not saying anything that I don't know what to correct.
E n times f, then n minus 1.
Very good. To be exact, as I mentioned last time, I should also say times x prime. Why don't I write x prime?
Because it's 1.
Because it's 1. Thank you very much. Because it's 1. Awesome. Yes. But keep this in mind. If I don't have x, plain x, for example, I could have 3x squared plus 4 to the 4th power. Well, this is not x. This is a power. And I want to differentiate this. Well, how do I do this? Well, I follow the same pattern, but now this is not going to be 1. So can anyone try? It's okay if you're wrong. Just try and tell me what to write so we can discuss this together. You follow the exact pattern. 4.
Will it be 4 and then 3x squared plus 4 and then 4 minus 1?
Good. Times the inner function prime. Inner,
And then 6x.
that's it. Awesome. Because this is no longer 1. Here I did not need this because it was 1. But here I have no choice. I'm not going to expand this. So the final form is 24x times 3x squared plus 4 to the 3rd. We did the exact same thing that we did with super plain x. I didn't tell you this then, but now I want us to understand the difference. There's only one difference. The inner function is a big deal. It's not a poor x. It's a big thing. So then I have to multiply by the derivative of the inner function. So let's practice this. There is more to the chain rule than just this, but let me log myself back in. Sorry, 1 second. It's considered me.